Alright, welcome to the last page of notes. And again, there's only 3 examples here, so this shouldn't be too bad. And what we're going to do is we're going to talk about 2 planes that are parallel if their normal vectors are parallel. That, should hopefully make sense, is that if their normal vectors are parallel, then the 2 planes are going to be parallel. 2 planes are not parallel, then they either intersect at a straight line. So here you see that these 2 planes are intersecting at this line right there. And the angle between the 2 planes, so the angle right here between the 2 planes is defined as the acute angle between the 2 normal vectors. All right, so we can use the normal vectors to help us find, what's that angle between where these 2 planes intersect. All right, and so let me clear this whole page up now. All right, and so given this, what we're going to be able to do is to tell, okay, where exactly are these planes intersecting, and is there a point? So find a point at which the line x equals 1 plus 2t, y equals 4t, and z equals 2 minus 3t intersects the plane x plus 2y minus z plus 1 equals 0. Alright, so the first thing that we're going to do is go ahead and just substitute in. Alright, if this intersects, if this, it's given in parametric form, but if this line that we have right here, if this line actually intersects our plane right there, then that means that, we can substitute in our x's, our y's, and our z's from our line equation into our plane equation. So that's what we're going to do. We're going to substitute in. So for x, we're going to put 1 plus 2t plus 2 times, now let's put in our y, 4t plus or minus, let's plug in our z, 2 minus 3t plus 1 equals 0. And now we're just going to solve this equation for t. And so we get 1 plus 2t plus 8t minus 2 plus 3t plus 1 equals 0. And then combine all of our t's. 2 plus 8 plus 3 is going to give us 13t. Combine, 1 minus 2 plus 1, and that's going to give us 0. So t equals 0. All right. Now, t equals 0 is where the line is going to intersect the plane. And so now we can actually find the point. And we're going to use our line to help us find that point. So our point where they intersect is going to be, we're going to substitute into our line equation what our t value is, which is 0. And so, I'll show the math. We'll get 1 plus 2 times 0. That's going to be our x value. Our y value is going to be 4 times 0. And our z value is going to be 2 minus 3 times 0. And so then our initial point is just going to be 1. It's an ugly 1. 1, 0, 2. And so our point where they intersect is right here, 1, 0, 2. And that's it. All right, example 9. We want to determine whether the planes are parallel, perpendicular, or neither. And if they are neither, then we're going to find the angle between them. I'll go ahead and tell you right now, this one's neither, but there is one in the notes that is neither, and I'm going to show you how you do that. And you're basically going to be using your cosine theta, which is equal to the dot product of the 2 vectors divided by the magnitudes, the product of the magnitudes of the 2 vectors, which you'll see in the notes. And again, if you have a question on that, just let me know and I can answer that. So here we're going to determine the planes are parallel, perpendicular, or neither. So let's go ahead and look. Here we have the equation of two planes. The first thing that I'm going to look at is okay, what are the normal vectors? And so the normal vector of our first equation is just 2, -3, 4. Again, it's the coefficients of our variables. And then I'm going to find the normal vector of the second, which is going to be 1, 6, and 4. Again, coefficients. Now, if these are scalar multiples of each other, then they're parallel and I'm done. Problem is they're not scalar multiples of one another. And so because they're not scalar multiples, then I do the next thing. Oh, let's see if they're perpendicular. How can I tell if they're perpendicular? Dot product. So n sub 1 times n sub 2, and that is going to equal, hopefully, 0. Because if it's 0, then they're perpendicular. I'm done. So let's see the dot product. We have 2 times 1 plus -3 times 6 plus 4 times 4. And we get 2 minus 18 plus 16, and it's 0. Because it's 0, because the dot product of these two vectors are 0, means that we have a perpendicular relationship.